Okay, at this stage, we need to see some document in the laptop. We want to show PFD, P&ID, and the symbology of the heat exchanger in PFD and P&ID. Before they starting the run of the simulation, process engineering team delivered to us the PFD and P&ID, and we can see the type of heat exchanger in the PFD and P&ID. That is why I want to show to you the symbology of the heat exchanger in the PFD and P&ID, and one time we can read the PFD and P&ID and take data from the PFD and P&ID and put in the software, for example. Thermal designer first need to find the heat exchanger location in PFD and P&ID and write and see the PFD location, PFD and P&ID data from heat exchanger. Please see. If you see in my laptop, this is one general process flow diagram. If you see here, the sketch of equipment available here. This is one of the heat exchanger, shell and tube heat exchanger. The tag number is 200-E-01. The fluid coming from this PFD, 200 PRPF 0101. Rich amine from rich amine flash drum with this stream come to this heat exchanger. Therefore, we need to know that what is the data as inlet. 212 is the data. This data available here. Temperature, pressure, flow rate, and in heat and mass balance attached to the PFD, we see that the composition of the fluid. Therefore, this stream is coming to the tube side of heat exchanger. In outlet, we have the other stream, 213, 213. This is outlet temperature. Outlet condition. Outlet condition show to us this is the inlet, outlet. That is why you see the temperature inlet is 70 degree of centigrade, reach to 96. Therefore, the temperature increase. Cold stream available here because the temperature increase. This heat exchanger show to us cold stream is located at the tube side. In shell side, bottom of this tower. This is the bottom distillation tower. Bottom of this tower is coming to the shell side. This is the temperature of the bottom, 220. Coming to here and come out, 221. This is the stream number. Hot stream available here. Cold stream is coming here. Please see this stream, 220. This is 220, it is liquid phase. The temperature is 126 with this pressure and with this mass flow rate. Outlet condition 221. We can find that in this table. Again, is liquid, the temperature is decreased. Hot stream available here. The temperature is from 126 reach to 101, and the pressure drop is coming here. You know, this is the inlet pressure, outlet pressure. By the checking the PFD, we can find that the inlet, outlet pressure in the tube side and shell side, inlet pressure, outlet pressure. That is, we can find the pressure drop in the shell side and tube side. The duty of the process engineer is providing this process flow diagram to deliver to us. We can find the tag number and we can find the process data sheet, a specific process data sheet for this equipment. In top pages, we see that this heat exchanger. Nomination of heat exchanger. This is the 200E01 lean rich amine heat exchanger. This is the service of heat exchanger. The hot side operating temperature, OP, that means operating temperature at inlet and outlet. 126 reach to 101.2. Cold side operating temperature, inlet and outlet, 17.9 reach to 96.0 degree of centigrade. The heat duty, Q, is available in this PFD. This is a 12937 kilowatt or 12.9 megawatt, near the 13 megawatt. Therefore, in PFD, we can find the location of the heat exchanger. This heat exchanger is available before this tower. Coming here, the fluid, process fluid is heated and reach to the tower. Preheater of the heat exchanger. This is a preheater for the tower. The product from the tower coming here and cooled and go to this side and sent by this pump to the process. Therefore, this is the process stream. Hot side process stream, cold side process stream. This heat exchanger like as a pinch heat exchanger to process fluid connected to the tower. One fluid at the hot stream, other fluid at the cold stream is available here. The name of heat exchanger is preheater, and the duty and specification available in the top. In top of this tower, we have other top heat exchanger, have a fan and motor. This is the air-cooled heat exchanger as a condenser. In same time, we can find this stream 215. In table, we have this stream 215. It is vapor available in this heat exchanger. This temperature 99.5 and pressure 1 bar gauge with this flow rate, mass flow rate 31989. Therefore, this heat exchanger inlet is vapor. What is the outlet? We can see 219 stream number. We can go to the 2119 stream number. It's a liquid. This temperature is 55.6, 1.7 pressure, and this is a flow rate. By considering the location of the heat exchanger, we can find application of heat exchanger. One of the most important things, if you have only one PFD, the heat and mass balance help to us to find the application of heat exchanger. This heat exchanger, as the air-cooled heat exchanger, have a fan, motor, and driver. The temperature is controlled at the outlet of this air-cooled heat exchanger. Is working for the condensation section. Therefore, vapor is coming inside the tubes, and condensation happen here. It is the condenser, maybe total condenser, maybe partial condenser. Condensation section accumulated in this vessel and back to the pump, by this pump to the tower as a recycle. Some additional gas available here in top of this vessel go to the filler. Therefore, PFD help to us the action and philosophy of the heat exchanger and help to us the type of heat exchanger. This is the shell and tube heat exchanger. This is air-cooled heat exchanger. It is working for air. This is working for the process heat exchanger, liquid services. By checking the service vapor fraction, we can find that the liquid services. Other heat exchanger available in the PFDs. This heat exchanger is kettle reboiler. The type is 200E02 A and B. That means two identical kettle reboiler available here. One of the process coming here go to the bottom of this kettle, and the vapor is released and come back to tower. Reboiler is working as a side heater system in the distillation. Every distillation column have a reboiler or thermosiphon. In the future, we can talk about the reboiler and thermosiphon. The product coming here and go to the bottom of the tower. Therefore, this is U-type heat exchanger. The type of front section is AKU. Generally, this type of heat exchanger show to us this is AKU, U tube, kettle section, and A as a flat cover. This heat exchanger works with the steam coming and provide from the utility and come from top to the tubes, and suddenly is condensed. Therefore, this kettle reboiler working with steam will be condensed in heat exchanger and accumulate for these vessels to this vessel, and send to utility again, steam condensate, to condensate recovery systems. This steam provides to us the vapor fraction for the tower. Reboiler as a side heater, side exchanger for distillation tower will be provide the adequate vaporization system to the tower. Therefore, in this PFD show to us, we have 4 heat exchanger, 3 heat exchanger. One is shell and tube as a pinch heat exchanger, 2 process fluid working as a heating and cooling. One is air-cooled system as a condenser, maybe partial condenser is happen, vapor is coming, condense is available in outlet. This heat exchanger as a reboiler working with the fluid system to provide the vaporization, adequate vaporize to the tower. This is working with the utility. Utility is steam. The condition of steam is most important item for the system. Therefore, by high-speed simulation software, we can provide heat and mass balance. Generally, when we have PFD, we can find the location of the equipment. One of these equipment is shell and tube heat exchanger or air-cooled heat exchanger. By stream evaluation, checking the stream condition, we can find the application and service of heat exchanger. One heat exchanger may be as a liquid-liquid service. One heat exchanger may be as a phase change heat exchanger. If you have the process data sheet, this data available in the process data sheet. In some general design condition, engineering consultant team deliver to us a simple thema sheet. Simple thema sheet delivered to the manufacturer. Manufacturer can find what is the service and what is the application of heat exchanger by mass flow rate evaluation. In the future, we can familiar with thema sheet, how can read, how can implement data, and how can extract data from the heat exchanger thema sheet. See again other P&ID. This is a PFD, we can see the P&ID. A simple P&ID available here. You see here. Let me show the full screen system. If you see here, this is one of our project heat exchanger available here. This is heat exchanger location in the P&ID. In P&ID, we have this exchanger E1903A, B, C, D. 4 parallel heat exchanger available here. This item show to us the tube side item. Therefore, one fluid is coming to tube side. This item show to us the shell side. Therefore, this heat exchanger as a shell and tube heat exchanger have a thermowell at inlet and outlet, have a vent and drain here, have a line sizing number 6 inch, and each line specified the size and dimension. The outlet condition from the E1903A will go to the process, and the inlet condition from this stream is coming to this is a parallel streams, parallel heat exchanger, 3 parallel and series heat exchanger. In P&ID, we can find in top of the P&ID the specification of heat exchanger. This is a service of heat exchanger. This is 4 heat exchanger, 4 identical heat exchanger with tag number 1903A, B, C, D. The dimension, size, specification, and type is similar to each other. The duty of each heat exchanger is 3062 kilojoule per second. Therefore, for the finding the duty and the process information, we can relate it to PFD and P&ID. 2 separate documents, PFD and P&ID, shall have same data, same configuration. But in P&ID, it is mandatory to show every item, like that A and B, separate A and B. E1901A, 1 heat exchanger. In similar, E1901B, similar again. But in PFD, we have one tag number. If you see here, in PFD 200E02 A and B. It is two similar heat exchanger with same tag number, but in PFD we can show only one heat exchanger. In PFD we cannot repeat the tag number, but in P&ID it is mandatory to repeat tag number, because in P&ID we shall know that how many heat exchanger working with parallel and series. That is the difference. All PFD and P&ID will be provided by the process engineering team to say to us what type of heat exchanger is available, what is the duty, what is the operational data, design data and operational data. It is mandatory provide PFD and P&ID by process engineering team. We are, as a thermal engineer, try to find the best condition of the process activity in heat exchanger. For better understanding, I will deliver this document to you to show that how many heat exchanger available in P&ID. The abbreviation is ABCD, that is 4. In PFD, repeat is not applicable. Therefore, we can show one heat exchanger. The tag number is ABCD. The data sheet, PFD, P&ID, information and data shall be same to run heat exchanger in the software as a data input in the software. Every data in PFD, P&ID data sheet shall be compliant to get the best thermal sheet.